Okay, the leukocytes, the white blood cells. You might want to jot this number down, 4,000 to 11,000 per cubic millimeter. So not nearly as many, obviously, as red blood cells, if you all probably already know. So what I'm going to do is, you will have to know the different, between the different white blood cells, and we got all 5 over there. Okay, so you're going to have to know which is which. All right. So what I want to do is go over here, and I'm going to form a little table up here talking about these. So the white blood cells, we divide into the granulocytes and agranulocytes. So of those 5, these are the granulocytes. If you can remember the name Ben, basophil, eosinophil, and neutrophil. Okay? Now these are not in the order of abundance. That's given to you on your handout that you need to know. And the agranulocytes, the monocytes, and the lymphocytes. So not the phils, but the sites. Okay? And you can go through and figure out, obviously, how you can tell the difference there. The granulocytes are formed in red bone marrow. Whereas the monocytes and lymphocytes are formed in lymphatic tissue. So they are formed in different areas. We talked about the lifespan of the red blood cell. So let's talk about the lifespans of these. The granulocytes have a short life. Measured in minutes to hours. So they're not around very long. Whereas the agranulocytes have a long life. From months to years. We all have a thymus gland. It's right in front of the heart. Okay. I probably don't have one anymore. It's probably gone by now. The thymus gland secretes certain lymphocytes, but they last your whole lifetime. So once they've got all those into your body and they're floating around, it doesn't have anything else to do. So usually the thymus gland will kind of go away. We never ever find a thymus gland in cadavers. We take the heart out and everything, but there's never anything there that looks like the thymus gland. And I don't think we even had them on models over here. I think we had got one somewhere over there in a drawer. We'll bring it out. Okay. Now, what is the function of white blood cells? What's the big deal? What's the importance? And of course, immunity. Okay? But let's break it down. We have specific immunity. Now that's the lymphocytes. Lymphocytes are very particular. They're very selective at who they kill. Okay? You've heard of antigen-antibody reactions. That's what we're looking at. Antigen, like antibodies, will only attack a particular antigen. So there are certain lymphocytes, You know, they're looking for a particular, particular someone to kill, all right? Very specific. But we also have non-specific. And that's Ben and the monocytes. You can kind of view them as the vigilantes in the blood. They don't care who they kill. They attack. If you're a foreigner, they're going to attack and kill. You're not supposed to be in the blood. They're the non-specific. Okay, so another thing which, you know, what makes them different from other cells that they can do this? You know, that they are protecting us from foreign invaders. So let's go through the 4 major characteristics of lymphocytes that help them in their immune process. They're amoeboid, which means they move around. They can move around different places. Most cells obviously are sessile. They're stuck where they are. They're not going to go anywhere. These move around. So they're amoeboid.
And this is non-specific?
Huh? No, this is,
is, okay. All of them.
yeah, all of them. All of them would be with these characteristics, okay? Chemotaxic. They're attracted to chemicals. You know, like plants are phototaxic. You put a plant in a window and all the leaves go towards the light, okay? And then you turn all that plant around so you can see the leaves, and all of a sudden next day they're back, you know, where they were. No, it takes more than a day. But they're phototaxic, they're attracted. These are attracted to foreign chemicals, basically, okay? Chemotaxic. Phagocytosis. You know, very briefly, when we were talking about cells, and I said, well, it's very important that you got to get things across the cell membrane. How do you do that? Well, you've got diffusion for a few things, a lot of things, active transport mechanisms to get things back and forth across the cells. But this is a process where you can get something into the cell without ever going through the cell membrane. It's called cell eating, okay? So what happens is the cell membrane invaginates like this, and it takes that foreign object into the cell, and then it clips off, and now it's like a little bubble there, surrounded by cell membrane inside the cell. And that's when it can be attacked and destroyed. The last one, diapedesis. Diapedesis. And this is my favorite all-time physiological word. Okay? I love this word, diapedesis. It reminds me of an old horror movie show called The Blob with Steve McQueen. Now this is the old Steve McQueen, not the new ones. You know, this was one of those movies, it was a big amorphous mass going around killing people, you know. So they run into their house, close the door, but to no avail, because that big amorphous mass could squeeze through the keyhole, or it could go underneath, you know. It was something big squeezing through a small space. It was performing diapedesis. That's what diapedesis means. White blood cells are relatively big, but they can squeeze through small holes or pores. Okay? So that makes it very easy to get into different areas. Now there's another, a couple of years ago, something else came out where you can put that word into a more modern thing. They had on MSN, an aquarium with an octopus. okay? And then they had another aquarium over here, and it was connected by a tube about that big around, okay? Tube. And it was showing you how the octopus could go from this aquarium to this one through that little tube. It was a big octopus. And as you know, an octopus has no bones. It's just jelly-like, you know. So it was performing diapedesis. It was squeezing through a small space, even though it's a pretty big animal. So that's diapedesis. Okay, that pretty much takes care of the white blood cells. Okay? You'll notice that we have over there another little beast. Doesn't look like any of those. That's the platelet. Okay? The platelets are not cells. They're parts of cells. And obviously, the numbers would be 250,000 to 500,000. 250,000 to 500,000 per cubic milliliter. Okay, so there's many more of those than there are white blood cells. Their lifespan is 9 to 10 days, so they don't live very long. Of course, it's not a whole living unit anyway. And they have two major functions. They're involved in two major functions: blood coagulation and platelet plug formation. Both of those is to keep you from bleeding more than you would if you didn't have it. Okay, so it's to keep you from bleeding very much. The platelet plug, it's just like a bunch of platelets getting together and plugging up a hole, you know. But there's also a platelet factor 3 that's involved in coagulation. But they both are doing the same thing. All right, so that takes care of blood. Yes?
So if you were to get something amputated, is that what clogs the veins?
When you what?
If you were to get something amputated, is that what would clog?
You know, when you know, people lose limbs, there is another thing that happens. You know, that's going to happen.
Yeah.
Another one is there's a vasoconstriction of blood vessels at the point
And
of
the
cutting,
vein just kind of
and
constricts.
that helps.
Wow.
You know, you're still going to bleed to death if you don't do anything. You know. But that helps impede the flow a little bit. You know, but you're going to have to wrap, you know, tie it off, whatever. So this is meant for smaller
Yeah.
cuts, obviously.
Okay.
Okay, so what's left is our tag-along lymphatic system. Let's talk about the lymphatic system. So what does the lymphatic system consist of? Lymph, which is a fluid. Now, we're comparing it with the cardiovascular system, okay? So it's got lymph, which is the fluid. It's got plenty of vessels, lymphatic vessels. There's lymphatic organs and lymphatic tissue. Okay, so let's make a distinction between those two. Up here you see things like lymph nodes. Lymph nodes, they're spread all over the body. A lymph node is a lymphatic organ because it's the only thing that it does is immunity. That's the only thing its function does, is to help kill invading organisms. But you'll notice that there are gut-associated lymphatic tissue, okay? So the intestines actually have lymphatic tissue embedded in them to help with the immune process. But obviously the intestines have other functions. So lymphatic tissues can be found in some of the other organs. But the lymph node is really the one major organ per se. Okay? So let's talk a little bit about the functions before we get into the actual anatomy of it. And what's the function? Well, obviously, we've been talking about immunity, and that is the major function. They make and distribute and maintain lymphocytes. You know, lymphocytes is the main cell of the lymphatic system and immunity. Okay, so that's the big deal. However, a couple more things which are really important as well. Have you ever heard of edema? You ever heard that word, edema? Which means a enlargement or swelling of a particular area of your body because of an excess amount of fluids accumulating in the tissues. Now, where does that fluid come from? Blood. Okay? Capillaries. But when that happens, and you can get transient, I'm talking here about a transient, you can get really severe edema as well. Let's talk about transient form. Maybe your foot swelled up for some reason. Okay? All that excess fluid can't go back into the bloodstream. Okay? It has to be removed in a different way. The lymphatic system removes it and returns it back to the blood. But it takes a while because, you know, you've got here, remember the cardiovascular system just got through. You've got a pump, all these arteries over here, capillaries, you know, all the venules over here, back to the pump. The lymphatic system, this half is gone. It doesn't have a pump. It doesn't have all these. It starts with the capillaries. That's where it starts. Okay? So that's one function. Another one, remember I mentioned the plasma proteins are supposed to stay